Group 7 elements. We've already covered group 1 elements. In periodic table, basically you have to cover group 1, group 7 transition elements, all right, and the transition elements. Group 1 man elements, we have already discussed that they are one of the best metals. Group 7 elements are the best non-metals. And how do we distinguish between a metal and a non-metal? By looking at their ability to gain or lose electron. A metal is called a very good metal if it is able to gain, if it is able to lose electron. The metal which loses the electron the fastest is called the most reactive and the best of the metals. And the non-metal that has a very good ability and a very fast ability to gain an electron or to accept an electron is the one which is the best non-metal. All right. We were able to discuss the reactivity of group 1 elements. We knew that the reactivity of group 1 or alkali element metals increases down the group. As you go down the group, their reactivity increases. Why? Because their power to lose electron also increases. Similarly, if you look at non-metals, it is the opposite way. As you go up the group, or if you go down the group, you will see that the reactivity of non-metal actually decreases. We'll write all of these things. I would just want you to have an overview to continue, inshallah. So group 7 elements are also called halogens. Halogens. All right, halogens. Should be understood that they are in group 7. So what should be the common in them? All of them have 7 electrons. 7 valence electrons in their outermost, or 7 valence electrons or 7 electrons in their outermost shell. 7 valence electrons, or you can say 7 electrons in their outermost shell. All right, the next point important is they are non-metals. They are non-metals. Okay, they are non-metals, और जब if they are non-metals तो फिर क्या हो रहा है? They are non-metals and they exist in diatomic form. What does diatomic form mean, Eileen? Like they exist in a diatomic, or you can say molecular form. We have already studied that molecular,
Yes.
or it is if whenever the word molecule comes, it means the bonding is covalent bond. Covalent bonding is present over there, right? Whenever the word molecule comes, it means it is a covalent compound. It has covalent bonding. So this means that they exist in diatomic form, F2, Cl2, Br2, I2. All right. This is the form in which they exist. Dear Ejba, is this making sense?
Yes.
Very good, very good. Very good, Lean. ये लिखें. They are non-metals and they exist in diatomic form.
Gcse.
Very good. Then, what are the elements? Basically, there is fluorine. You can say the halogens are fluorine, then chlorine, then bromine, and then iodine, astatine, which is ATO3. I, Br, Cl, and F. All right. They all form a negative charge, which means they all have a capacity. This means they only gain one electron per atom, right? To complete octet configuration. All right. Like what? Fluorine, one negative, chlorine, one negative, bromine, one negative, iodine, one negative, like that. They have Jirijba, are you writing?
Gcse.
Right. The next point that we have to keep in mind is that they make, they have colored, they are, rather, we should say that all right, they, so they basically make, uh, they have, they are colored. You can say they are colored. Their color gets darker down the group. All right. What else? These are the few physical properties we are going to be discussing. They have low melting and boiling points. Obviously, is this clear?
Yes.
Lean, up till where have you written? Yes, Alishba, up till where? Are you on the last line?
सर ऊपर. सर जी सर यहाँ से.
Alijba, you were not writing in the beginning?
नहीं सर, यहाँ से नहीं, थोड़ा नीचे।
No.
जी।
So these are general properties of halogens, basically. Physical properties, obviously. But we are going to be discussing in detail each one of these properties, how they change when you go down the group. If you go down the group 7, how these properties they vary going down the group. This is what we still need to discuss. This is just a general idea that all of them are covalent compounds. They all have 7 electrons in their outermost shell. They have low melting and boiling points because they are non-metals. They have covalent bonding in them. They form color. They are colored themselves. As you go down the group, the color becomes darker. Okay, we'll talk about like chlorine. Excuse me. Chlorine is a greenish yellow gas. Bromine is a reddish brown gas. Chlorine is greenish yellow. Bromine is reddish brown. Iodine is purplish black. This is so they are colored, and you see as you're going down, their color is becoming darker and darker. Is this clear? Alishba, have you written all of it?
यस।
So let's move ahead. So
मेरे मोबाइल की फुल वॉल्यूम है, लेकिन मुझे आपकी आवाज कम आ रही है।
is it better? Eileen, is it
यस।
better now? Okay.
यस।
All right. So now we are going to be looking at some of the trends, basically. Trends. If you generally, we know generally when we are doing periodic table, we know down the group what takes place. Number one, atomic size increases due to increasing shells. If you go down the group, when you go down the group, the period changes, right? As the period changes, it means more shells are being added. Third period, fourth period, fifth period, the element that is in the third period, the atom in the third period has 3 shells. If you moved a step down, you're going to see in the fourth period the next element has 4 shells. So as you're going down, the size of an atom is increasing. The atomic radii is also increasing. Then you also see that mass increases, right? As you're going down, the atomic mass is increasing, right? Is this clear?
यस। यस सर।
Right? So there are certain things. These are the general things that we were able to do. Specific things we have the same thing. Atomic size is increasing. We're talking about down the group. You're moving from fluorine, chlorine, bromine, iodine, astatine. We are talking about them. Down the group. What are the things that are taking place down the group? Number one, atomic size increases. Number two, number of protons and electrons is also increasing. Right? Atomic size increase due to shells. Shells increase. That is why the atomic size is increasing. If you are going down the group, there's going to be period 2, period 3, period 4. period 5, period 6, right? You understand? So if you're moving down the group, you're going to experience an increase in the shell that increases the size, right? What else? If you're going down the group, mass increases. You're talking about atomic mass. Why? Because there are more number of protons and there are more number of neutrons. They're increasing the atomic size, the mass. If you increase the mass, you will see down the group intermolecular forces also increase. Particularly van der Waals forces. Van der Waals forces. Van der Waals forces were the ones which facilitated what? Melting points and boiling points. Intermolecular forces are the ones, the factors between that is present between the molecules that does what? That gives brings the atoms closer to each other, right? Once they are closer to each other, they are going to gradually enter in from the gaseous state into the liquid and from liquid to solid. Do you understand? Intermolecular forces increase. Van der Waals forces, intermolecular forces increase, specifically increase in van der Waals forces, the melting point and boiling point.
Sir, I didn't understand.
All right. We have already talked about this when we were doing atomic structure. We said that among the molecules, between the molecules, there are different type of attractive forces. We were able to discuss one of the force which was intermolecular force, which was van der Waals force, right? Van der Waals force is one of the intermolecular forces that takes place between the molecules of same atom, same element, right? Can you recall a bit now?
Yes.
Intermolecular force. So when intermolecular forces increase, the particles they tend to come closer to each other, right? When they come closer to each other, they from a gaseous state into a liquid state. They become what? What happens? Basically, if the intermolecular forces increases, the molecules are going to be closer to each other. This is going to make a loosely packed arrangement. And loosely packed arrangement is often present in what? In liquids. So basically, it, intermolecular forces, they depend upon, lean intermolecular forces depend upon the mass, the atomic mass. As the atomic mass increases, you're going to see as the atomic mass increases, the melting point and the boiling point also increases. You understand?
Yes, sir.
Okay. So what is going on? As you're going down the group, the atomic mass is increasing. There's a rise in the atomic mass. This increases the intermolecular forces. What type of intermolecular forces? Specifically van der Waals force. When the van der Waals force or the intermolecular force increases, this increases the melting and boiling point. Increase in van der Waals forces increases the melting point and boiling point. How did that take place? We know that these are the particles of what? These are the particles of gas. They're widely spread apart. And we know these are the particles of a liquid, which are loosely packed, not widely spread. We know these are the particles of solid, which are tightly packed together. You understand? And these are mobile, they can move around, but they can only vibrate at their fixed position, right? Eileen, are you getting it?
Yes, sir.
So when the van der Waals forces increase, they bring these particles closer to each other in this
Sir,
way.
what is a van der Waals force?
Van der Waals force is a force, attractive force between two molecules. Okay, it is an attractive force between two molecules.
Okay.
So as the number of electrons and protons, as the mass is increasing, that is going to increase the van der Waals force. Once the van der Waals force is increased, the particles are going to come closer to each other. Do you understand? When they become closer to each other, it requires more energy to melt them or to boil them. Is this clear?
G. Yes, sir.
Okay, so if you're going down the group in a halogen, in the group 7 element, you will see that there is a gradual increase in the melting and boiling point, right? And this increase in the melting and boiling point is due to the van der Waals forces or the intermolecular force that is present over there. Because as you are going down the group, as you are going down, I'll write this down. As you go down the group, atomic mass increases. This increase causes a rise in attractive forces between molecules. This causes an attractive forces between the molecules. All right. This attractive force, this attractive force is actually the van der Waals force. Okay, this is called the van der Waals force. Van der Waals force. Van Van der Waals forces. Do you understand this now? So if you're going
Yes, sir.
down the group, the particles are coming closer and closer, molecules. So if you look at fluorine, fluorine is a gas. If you look at chlorine, chlorine is a gas. If you look at bromine, it's a liquid. If you look at iodine, tends to become solid. You understand?
Yes.
Okay. So as you go down the group, the atomic size increases. This increase, this increase causes a rise in the attractive forces between the molecules, the van der Waals forces. And this increase in the rise in the van der Waals forces causes the melting point and the boiling point to what? The melting point, the boiling point increases down the group, right?
Yes.
Is this point clear to you?
Yes.
Similarly, if you look at it, what is going on? Fluorine is a gas. So its particles are going to be something like this. Chlorine is also a gas, but has a larger atomic number. It means there's going to be some attraction between the molecules. So they're going to be pretty close to each other. If you look at iodine, because this is gas, iodine, sorry,